And now we're going to start with our first presentation of today, and we're going to welcome our keynote for today's symposium, Dr. Amy Zanne, professor and Aristides Endowed Chair in Tropical Biology in the Department of Biology at the University of Miami. Welcome, Dr. Zanne.
Thank you so much. It's great to be here, and I appreciate the welcome.
Well, thank you. I hope technology is more forgiving with you this morning than it has been with us, but the virtual floor is for you. It's all yours. Take it away.
Great. Well, I'm going to try to share my screen now then. All right. Well, thank you so much for the invitation to talk to all of you today. It's my pleasure to join, and I'll tell you a bit about global biodiversity and its threats under climate change. And at the start, I'd just like to thank that I have many collaborators and colleagues around the world in different funding sources. And I'll start by just giving you a little bit of a background about who I am. And so I am a new faculty at University of Miami. What we do in my lab is try to understand where biodiversity is distributed around the planet, and then thinking about how that biodiversity contributes to the storage and release of carbon. We do that especially by focusing on forests, especially trees, and then looking at the tree stems themselves. So sometimes we look on the outside, and other times we're looking at the inside of those tree stems to understand the jobs that tree stems have to do. So trees are, you can see the wealth of ways that trees are constructed. And so what they have to do is they have to transport resources long distances from the roots to the leaves, store different resources such as carbon, and then support those leaves high above the crown. And some of that is by looking on the outside, and other times looking at the inside to see how plants are growing and doing these different jobs in, say, wet and dry places around the world. But more recently, I've been increasingly interested in the plant afterlife. How is a plant constructed to live, affecting how it decomposes and releases carbon back to the atmosphere? And so to do that, that's brought us to increasingly looking at who's doing that decay. We call these the decay agents. So globally, termites and bacteria are important decay agents, breaking down wood. But in the tropics, termites become incredibly important. And this is something we've recently increasingly recognized. We also have things that are non-living that break down wood. So solar radiation bleaches wood, releasing carbon dioxide. And then you have fires that burn in particular places in the world. And so with all of this, carbon is being lost back to the atmosphere as greenhouse gases, methane and carbon dioxide. We need some of these, but we don't need too much. And to do these different projects, we move around the globe documenting biodiversity and the carbon storage. So we work in places, we've worked extensively in Australia, more recently in Brazil, and also in places such as France to take observations of where that biodiversity is. But we also do experimental manipulations to try to understand how linking biodiversity and how wood is constructed to how it's releasing carbon across the globe. And so with my shift to University of Miami, we're increasingly working in a site in Brazil, which has a seasonally flooded grassland. And so we can contrast the wet versus dry season to see how that grassland is storing and releasing carbon. And then also with my shift to Miami itself, we're very interested in how sea level rise and episodic storms are going to cause increasing deadwood contributions to the landscape and how that deadwood is decomposing, especially in places such as mangrove forests. So with that, I'm going to turn to the topic today. And so thinking about biodiversity, and I want us to start by thinking about why should we care about biodiversity? Why is biodiversity important to us? And I'm going to suggest that our lives are intimately intertwined with the biodiversity around us. Scientists have come up with what are called a list of ecosystem services about how we depend upon biodiversity. There are provisioning services. So biodiversity provides the food we eat, the building materials for the houses we live in, and the fibers for the clothes we wear. There's also provisioning service or regulating services. Regulating services are things like the air we breathe. It's because photosynthesis arose on the planet where plants and other photosynthetic organisms release oxygen with photosynthesis that we actually can exist and breathe air and use the oxygen that's available to us. There are supporting services such as pollination and nutrient cycling, and there are cultural services. So around biodiversity is where we exercise, where we go for spiritual reflection, and many other such things. And so I challenge you to sit and look around where you're sitting right now and think about all the different forms of biodiversity that you're surrounded by right now. I've been involved in a project that's recently is about to be published, led by Janine Cavender-Bears and working groups based in Annapolis, Maryland, where we were interested in revealing the hidden value of trees in the US. And so what we did was we quantified how many $1 billion per year are trees contributing to different ecosystem services. And what we found is that trees are contributed around $60 billion per year to carbon storage, around 45 to air pollution removal, and also contributing important wood products, tree crops, and Christmas trees. So all of these are contributing to our economy. We then wanted to ask where across the tree of life, we call this a phylogeny, are we getting these different ecosystem services? And so you can see here that this is close branches are more closely related species. We have things like the pines, cherry trees, oak trees, and maples, all distributed across the tree of life for trees. And what we found was that we are getting these services broadly distributed across the entire tree. Finally, we wanted to understand what are the major threats to these ecosystem services provided by trees. And so you can see here surrounding this phylogeny are the red bars. The size of the red bars are how threatened different species are. We can see that fire threatens species around the entire tree. Certain species are particularly prone to pests and pathogens, but that all species are at risk of climate change. So we gain incredible amounts of services from trees, but they're at great risk. So to understand biodiversity and its threats, it's really important to begin by thinking about how much biodiversity we have and where is it distributed around the world. And so from a study about 10 years ago, we know that there's about 9 million species on the planet, or there's estimated to be about 9 million species on the planet, with about 2/3 on the land and about 1/3 in the ocean. But to date, we've only found about 1.2 million. So only about 1/10 of that, we only know about 1/10 of the species. So there's many left to be discovered. If we look at where species are distributed around the globe, we know that the tropics contain more species than the temperate and the boreal zones. And we call this the latitudinal diversity gradient, with greater species in the tropics. We can take a different lens and think about where in the earth are most unique species found there and no place else. And these are the hotspots, the diversity hotspots. And we can see that each continent around the globe, except for Antarctica, has hotspots of endemic species that are unique to those places. A third way we can look at biodiversity is to think about how much biomass it contributes. So here on the left, you can see that plants overwhelmingly contribute the most biomass of all biodiversity, with 450 gigatons of carbon. That's followed by bacteria and then fungi, with archaea and animals contributing smaller amounts. If we blow up this animal triangle, what we can see is that the arthropods, the insects, are contributing the most biomass, followed by fish. And we humans here are sitting with a small fraction of that. So we know something about what biodiversity is and where it is. How do we come to that knowledge? And we know where species are based upon centuries of explorers documenting that diversity. There are certainly many important early explorers that we can all name. But I think what's often overlooked are some of the important women explorers from early times. So here's Maria Cibala, who was in California in the 1600s, and she was an artist who would draw the diversity she saw. She, interestingly, was one of the first people who described the metamorphosis of insects, how insects change from larvae to adults. Before that, people mainly thought that insects just arose from the mud. So she gave us new insights into that biodiversity. Here are two of my students in Brazil looking for termite biodiversity. And so as we're collecting this diversity, what many of the collectors and the researchers and scientists do is we bring those back to collections so that we can continue to examine that diversity that we find. And those are warehouses such as museum and herbaria. But there's some really exciting recent technology advances that have let all of us contribute to documenting biodiversity. And so here's the iNaturalist app with the records that people have contributed from around the globe, and I've contributed many records myself. And so you too can document diversity. This is the fastest growing knowledge base that we have of where biodiversity is found. And so then we have the Global Biodiversity Information Facility that brings this diversity together and shares this to the world. So you can go online and look to see where species are distributed. We see that we have about 1.5 billion records of animals around the world. And so we have good records to see where species are distributed all across the land and the sea. We have less knowledge of viruses. We know that viruses are everywhere, but we have big gaps in where we see them being recorded. So we know what species, how many species or estimates of species and how they're distributed. Let's then turn to thinking about their risks. So this is, as Yoka just recently said, this is an important week for news, and that the IPCC has just had their 6th assessment report. What they're showing here is our projected expectations of how much the Earth will warm. And so we have from the 1950s up to 2100, and with 0 to 5 degrees warming. And what you see here is that we've been sitting at about 1 degree warming, with the projections, with the best case scenario is that by mid to end of century, we'll be at 1.5 degrees, with some of the worst case scenarios sitting at 5 degrees or more. And so then here we can look to see what that impact is, or the estimated impacts on the terrestrial and freshwater ecosystems and the ocean systems. Here you can see the 0 to 5 degrees warming, and this is our 1 degree baseline where we're sitting today. If you see here, the red is very high risks and the white is undetectable. And so you can see that biodiversity loss on land under a 1.5 degree warming is moderate to high. If we contrast that, we can see here corals, and even sitting at just 1 degree, they're already at high to very high risks. So our biodiversity is at massive risks. And so we can turn to what the numbers look like. So under IPCC's recent assessment, with a 1.5 degree warming, we're expecting to lose up to 14% of our species. And with a 5 degree warming, we're expecting 48% of our species. Oceans and coastal systems are between moderate and very high risk of loss of species at just 1.5 degrees C warming. And in some studies, they're suggesting that in the next 10 years alone, we're going to lose 1 million species. So close to 1/10 of our species might be lost just in the next 10 years. And we're already seeing those losses. So here's the first mammal that's been lost. The Bramble Cay melome, it was only found in islands on the Great Barrier Reef. And with sea level rise, this species has been lost. There's been extensive searches for this melome, and it's no longer found. So we have lost this species forever. So one thing you might say is, yes, it's happened before. There have been mass extinctions, and we've had a series of mass extinctions through our ancient history. And so you can see that in the past, we've lost it's estimated 70 to 96% of the species were lost. When those species were lost, other groups came to dominate. So with the extinction of dinosaurs, mammals came to dominate, and the dinosaurs took over from another group from past extinction events. But I think we want to sit with that and consider, yes, the Earth has recovered before, but what is the landscape as it recovers from whatever we're doing to it today? We don't know which lineages are going to be lost, which species, and that includes ourselves. And so we know that species are at massive risks. Let's think about what climate change is and where it's happening. So we know it's warming, and we know it's alterations in precipitation, as well as greater and more extreme and more frequent extreme events. And so if you were also watching the headlines this week, you might have seen that Eastern Australia was hit by a massive cyclone. So this is Lismore, where flooding occurred up to the 2nd story of many houses. Climate change is not happening equally across the globe. This is the velocity of climate change, and red means that the speed of climate change is happening faster than in other places. And you'll see us sitting here in Miami are sitting in one of these rapidly changing places. So climate change is differentially affecting biodiversity around the world. Why is biodiversity threatened by climate change? Well, let's think a bit about the biology of these organisms. And so if we think about mangroves like to live in tropical to subtropical places along coastlines. So they have based upon how they're constructed, they like to live in particular places in the world. Similarly, here is sugar maple, and sugar maple is what we use for we make maple syrup out of. That's known from the northeastern North America. Now, what you can see is that each of these species, just like Goldilocks, likes their environment just a certain way. They don't like it too hot or too cold. They don't like it too dry or too wet. And so when their environment's shifting, their climate is changing, all of a sudden they're no longer sitting in the place that they like to be. They're also having to, not only are they having to handle environmental conditions, but they also have to handle how they're interacting with other organisms. And so they're competing with other species, perhaps fighting with other species, and that includes fighting off pests and pathogens, which all might be similarly affected by climate change. And so here you can see, this is the projected shift in sugar maples. So here we have where sugar maples have been in recent decades. And this is what the expectation is by the end of the century. We're expecting to largely lose sugar maples in the continental US, and that we're going to have to solely turn to Canada to provide our maple syrup. So let's think about what species can do if their environments are changing around them. Well, they have 4 options. One of them is that they can move. For them to be able to move, it's helpful to have characteristics that let them track the rate of change of climate. And so having things like wings can be helpful for moving faster than if you can only crawl. Organisms can also adjust. And so you can think about if animals have burrows, perhaps they spend more time below ground, or they can adapt. And that's where their genes are changing to help them to adjust to these shifts and to tolerate these shifts in the environment. And so we have some evidence that corals and their algal associates are showing some adaptation and adjustments in their tolerances to these rising temperatures. But whether they can adjust or adapt fast enough to the extreme temperatures is really of question. And if organisms can't move, adjust, or adapt, then what we'll see is that they'll die. And so we're all watching the fate of polar bears as we're watching their ice melt around them. So one of the great places to try to understand some of these expectations of climate change is to look to mountains. And so in mountains, you have in a short space a big change in the environmental conditions. And so here's one study that looked at Andean birds, the birds that eat fruits, and they looked to see at the lowlands, what are the species there, mid elevations and high elevations. And what their expectations were based upon the known preferences of the habitat for these species is that the expectations that most of the lowland birds only few lowland birds would be able to stay in place. Most would have to shift to higher elevations. And one of the thoughts, and we're getting increasing evidence of this, is that if you're a high elevation organism adapted to the tops of mountains, you have no place to go, so that you're going to be lost as those climates shift. So that's their predictions. What sort of evidence do we have that species are responding to changing climates? Well, we know that Atlantic salmon are spending increasing amounts of time moving up into Arctic waters. We know that tree swallows are shifting their phenology when their reproductive biology is happening. They're laying eggs earlier and earlier in the year. We're finding that sea turtles, their sex is determined by the temperature where the eggs are laid, and that females are more common in the eggs as temperatures are warmer. So we're getting clutches of sea turtles that are almost completely females. And then we're finding that various invasive species that really like these warming conditions are doing better and better. So water hyacinths are from the Amazon originally, and now they're found in every continent except Antarctica, clogging our waterways. So we're seeing a lot of different responses. One of the interesting responses to think about is the phenology of organisms. And so as seasons change in seasonal places, you find certain behaviors happening. So you might find flowering in the spring or leaf fall in autumn. And so one study found that 87% of the animal and plant species they were studying has shifted their phenologies earlier or later in the year. What becomes really critical is thinking about if these species depend upon one another and they're using different cues. So if the hummingbird is looking for the cue of the day length, whereas the flower is looking for temperature, they're going to be mismatched and no longer find one another to trade pollen and nectar. And that can be critical for these species. So what do we know about extinctions happening around the world? Well, here we can see from 1500 to 2014, you can see the risk of extinctions, and we have this background rate that was happening just above 0 for the rates of extinctions. And what we've seen since the early 1900s is that there's been this fast uptick in all sorts of vertebrate organisms, reptiles, amphibians, and fish. Birds and mammals are all experiencing elevated extinction rates, all in line with this time period over which we're experiencing these warming climates. And a great case example are the amphibians. So these are things like frogs and salamanders. We know that there's about at least 7,000 species of amphibians, but we're still finding more and more today. And we know that where we're seeing a massive decline is in amphibians. This is one of our banner headlines, is seeing amphibians around the world decline. And we don't really know all the reasons why, but we believe that climate change, habitat loss, pollutants, so they breathe through their skins, and so they're very sensitive to pollutants. They're competing or being outcompeted or eaten by introduced species, disruption by ozone, overexploitation, and disease spread, especially from things like the chytrid fungus. In fact, the golden toad that was first only discovered in the 1960s has been documented to be extinct and lost to us in the mid-1980s. So we're having rapid declines in different sorts of species. So we know we're losing species. What can we do about them? What are the solutions? Well, one of the things to think about is, what are our goals? What do we want to protect? Should we be targeting genetic diversity, as that genetic potential can allow species to adapt into the future? Do we want to protect each of the species? Is it important to protect the evolutionary diversity? So things like tuataras and ginkgos are really unique lineages with few close relatives. Do we want to protect functional diversity? We know that legumes, things like beans, are nitrogen fixers, so really helping to improve our soils. Do we want to keep intact these networks, like the plants and the pollinator, that hummingbird and that flower? Or do we want to target particular ecosystems around the world? These are all laudable goals that we should be keeping in mind. And so I was part of a really interesting group back in early 2020. And so there had been a planned UN Biodiversity Conference that should have happened in October 2020, which was disrupted by COVID. And so instead, they met in October 2021 and will continue in April and May of 2022. And so these are a bunch of policymakers coming together. Sandra Diaz is a colleague and collaborator, and she wanted to be proactive so the scientists could give recommendations rather than responding to the policymakers. And so we met in Davos, Switzerland in February 2020. This was my first Zoom meeting, sitting remotely, which little did I know how frequent this was going to become in my life. And so what we came up with is a recommendation that we need a safety net made up of multiple interlinked and ambitious goals to tackle nature's alarming decline. And so we wrote a position piece, and we also published a paper. And what we came up with is a series of goals that we can target that have to do with ecosystems, species, genes, and nature's contributions to people. If we stay business as usual where we are right now, what we'll find is low ambition with decline. If we have medium ambition, we have an uncertain future. And if we really want to target protecting biodiversity, this is our road to recovery. And what we should be doing is having no net loss of ecosystems, minimal loss of species, conserving 90% of the genes, and having a broad range of nature's contributions to people protected. So what does this look like on the landscape for you and me? Well, we can act locally and globally as we're thinking about protecting biodiversity. These are broadly divided into two categories. There's mitigation, where what we're trying to do is reduce the rate of change of temperatures by doing things like reducing the emissions of carbon. We can also help biodiversity to adapt or adjust, in this case, to their changing environments around them. And so it's really important to reduce our carbon emissions. We can also help protect individual species. We can protect them. We can assist their migration. So in British Columbia and Canada, they're moving Western larch seeds 1,000 kilometers northward so that to help them to track their shifting habitat. There's also, we can try to eradicate invasive species. So Miami was run over with a giant African snail. And so over a 10-year period with $24 million invested, this snail was eradicated. And there's been a really interesting harnessing of new technologies. So the Nature Conservancy in California was seeing that shorebirds were declining. And so what they did was they took their maps of shorebirds and their migration pathways. They thought that the migration pathways were what was at risk. And then they took surface water and they said, this is where we expect that surface water is available. They mapped these two together, and that gave them these gaps where they said that these are the areas that would be really valuable to conserve. So what they did was they paid rice farmers $1.4 million in reverse auctions. So they kept their lands flooded at critical times for migrating birds. And what this has shown is that shorebird diversity has increased. So there are ways to target individual species And it's costing things like millions, millions to tens of millions of dollars to protect these individual species. With 9 billion species at risk, though, this is going to be hard to protect all of biodiversity. So another approach is to really target ecosystems. And so we can think about where they're most diverse. We can also think about where most of the carbon is stored. And so we know that the bulk of carbon is stored below ground, deep in the crust and below the ocean. But we also have important stores in the surface of oceans, in our soils, and in the plants themselves as they're interacting with the atmosphere. What you see in the red are the fluxes where carbon's going up to the atmosphere or being taken up by the land and the sea. And so there's been some really interesting recent headlines that you might have seen. This is a New York Times little cartoon talking about peatlands. So peatlands only make up 3% of the land on Earth, but they store twice as much carbon as all the world's forests combined. So they might have seemed sort of swampy and ugly, but they're incredibly important for biodiversity and carbon storage. So we might think, I think an important place to put our efforts is to think about helping those habitats that are both rich in diversity and rich in carbon stores. These are our peatlands, our forests, our seagrass beds, our mangroves, and our coral reefs especially. And so I think if we turn back to the IPCC's sixth assessment report, you'll see that they describe that the fate of humanity, the fate of us humans is intimately tied to the fate of biodiversity. We both depend on one another. And so safeguarding biodiversity in ecosystems is fundamental to climate resilient development. Maintaining this resilience and ecosystem services at a global scale depends on effective and equitable conservation of approximately 30 to 50% of Earth's land, freshwater, and ocean. So we have our marching orders. But I think these are big goals for organizations and people, but you can make a difference too. So I think, what can you do to help? One of them is that you can document diversity before we lose it. It's important to know where it is so that we know where to go looking for it in the future. You can reduce your carbon emissions. You can protect species, especially by protecting habitats. You can get involved, you can ask questions, you can learn, and you can vote. And these are all things that we can do as individuals. And as I'm wrapping up, I want to turn to, this is an artist, Donna Davis, that I work with in my Australia work, where she's helping us to highlight, to show the world the hidden diversity that we work with. On the right, this is a termite diversity gradient where we go from our wet to our dry places, and it's showing our termites. This is, she entitles Mirror, Mirror on the Wall, who's the loveliest of them all, to show that even the small things are quite beautiful. She's working with other scientists that are studying mountaintops at risk in Australia, where we're expecting to lose species off the top of them. And so this is a video you can go and watch where she's trying to expect the fate of this poor plant that's being lost as it races around the urban concrete jungle, trying to find a new home. So with that, I'll stop and take any questions. I appreciate your patience with following me today. Thanks.
Thank you so much, Dr. Zanne, for that insightful presentation, and especially for the reminder that our fates, humanities and biodiversities, are so closely linked. So I think we really need to put it front and center when we talk about the climate crisis. We actually have a good amount of time for some questions, and we have some, so let's get started. First question from Christy is referencing the extinction events that you talked about earlier in your presentation. She says, I know most of life went extinct during the various historical extinction events, but what was the time frame of those die-offs? From what I've read, it seems that the Permian extinction, the largest one, took place over millions of years. In geologic terms, our current mass extinction taking place over centuries or even decades seems to be an entirely different category than extinction event, rather more accurately an annihilation event. Would you be able to clarify the duration of past mass extinction events and if they took place over millions of years?
That's great. Thank you, Christy. Thanks for that question. This is not an area that I'm an expert on, and so I will, but my understanding is similarly to yours, that yes, indeed, many of these past events happened over much longer time frames by a long shot, and the timing of our individual lives and our lives as humans overall. And so that the rapidity with which we're losing species is quite extreme. So I believe you are exactly correct. Thanks.
We have another question here from Johan. I know you have a lot of experience working with trees, Dr. Zanne. He's specifically asking about the impact of ocean acidification on buried mangrove roots, especially what's going on here in Miami Beach. Do you have anything or any insight to offer on that?
I don't know how mangrove roots might affect ocean acidification. Certainly decomposition is really tied to the pH and how acid or not, and the organisms respond to that. But I think, I don't know specifically. Often decomposition is thought to be slowed when things are submerged. And it depends on really who's doing that decomposition and whether they're absorbing, how they're affecting the acidification. So I don't have much to say on those interactions. I would imagine that the small amount that mangroves contribute to where they're interacting with the oceans, given the vast amounts of oceans, there's probably not a huge effect on the acidification and the rates of acidification.
Thank you. We have several more questions. This is a good one, because at CLEO, we're always asking folks to take action, and sometimes advocating on a specific issue can be difficult. And so they're asking, a lot of environmental protection actions face pushback from large corporations and their influential lobbying efforts. When so many people are thinking or focused mostly on the economy, how can we make the case for biodiversity?
I think that a lot of what drives us is thinking about the short-term gains and wins of our economy, and it's really that what we need to think about is the long-term. Where are we going, and what's going to happen if we lose this biodiversity? And what you hope is that people want to think towards our futures, think about their children, their grandchildren, and what we're giving them to inherit. If we can motivate with that, I think that's our best hope. And I see that a lot of people seem short-sighted and thinking about what's happening in their pocket this year, next year, the next 10 years. And at the rate that we're barreling, we don't provide a very hopeful future for those that come following us.
Thank you. This is an interesting question, something that's popped up on my radar as well. And I think you may have some insight. They're talking about research that's been done showing how some natural habitats that used to be good carbon sinks are becoming less good at pulling CO2 from the atmosphere, or even they're becoming carbon emitters. Do you know how this happens and how we could restore that? Or do you have any examples to give?
Yeah, I think, right in our backyard here in Miami, the Everglades, I think, is shifting. We're also seeing Amazon forests with climates changing, and the plants that even trees respire, so they're photosynthesizing and taking up carbon, but they also respire just like we do in their tissues and releasing that carbon back. And so as their functions are failing and they're less able to fix the carbon with photosynthesis, they're respiring, they're decomposing, they're releasing that carbon back. And so it's not just the trees, it's in the soils and their ability to hold in the microbes that are there. And so I think in these systems, what we're tipping is the balance of how they're functioning, so that they're no longer able to take up as much carbon, and they're starting to release and flip such that they're instead releasing more of that carbon than they're taking up.
Thank you. Next question, I actually like this one as well. What's a part of the biodiversity discussion that you feel doesn't get talked about enough? Some people say fungi are underrated. Folks often focus on charismatic species when we talk about species loss and extinction. What would you want people to know that maybe we haven't heard before that's really important, especially in the conversation of the intersection of climate and biodiversity?
Right, and so a lot, I started with the big charismatic trees as my study system, and as you saw, I've increasingly moved into studying the little things in life that move the world forward, and I think thinking about the importance of microbes, so bacteria, viruses, fungi, what they're doing for us when they're hidden and we don't see how they're working. Just because we don't see them doesn't mean that they're not doing important services for them. Whether we have to have decomposition, we have to have carbon release back. We need that blanket of CO2 and methane that's provided, and that these are the fuels that are doing that. But these are also where our emerging pests and pathogens are. And so thinking about the pandemic that we're sitting in, this is a virus that's emerged, and so better understanding these little things is incredibly critical. I got a lot of pushback as I was starting to study termites, and so my lab adores termites. I know that they can be very problematic to many of our houses, but that's a small slice of the total diversity. And so we're finding that they have an incredibly important impact on carbon cycling in tropical regions, perhaps cycling up to half of the carbon that's found in wood. And what we're showing is that they're much more sensitive to temperature rises than the microbes. And so with a 10-degree increase, you're going to rapidly increase the amount of decomposition, threefold more than bacteria in terms of breaking down wood. And so as what we're going to see is that as we decrease that limit of them sitting just in the tropics to more and more subtropical regions, or as we have tropicalization, as we're sitting in one of those places very much tropicalizing, what we're going to see is the effect of termites is going to increase around the globe. And so I think trying to understand what these little things are doing is incredibly important.
Thanks. Is it true that termites are the largest natural source of methane in the world?
That is a great question. I am not sure if that's true, where they stack up relative to cows. I am not sure. The termite, if you look at that graph where I was showing biomass, and I showed you that pie slice of humans, which is I think about 0.06 gigatons, that's the same biomass that termites have. So termites and humans have similar biomass on the planet. Livestock was right next to humans in that pie slice, but I don't know how that's divided between, say, cows and sheep and goats and things like that.
Thank you. We have time for one or two more questions. This is an interesting question. I know you're a professor at University of Miami and you teach young adults. This question is asking about how can we teach kids about biodiversity in an urban setting, given that there isn't a lot of biodiversity in these areas?
I would argue that that's not true. I would argue that there's a lot of biodiversity around us. It's not necessarily native biodiversity, but we're surrounded by plants and grass in our backyards, and there's also a lot of the little things there, the insects and things like that. And so when I was teaching, I just came from teaching in Washington, D.C., and with the pandemic, I had students documenting in iNaturalist the biodiversity in their backyards and seeing how many different things they could see. And there's iNaturalist has a city challenge that all of us can participate in, and people are documenting hundreds of organisms just in their backyard, so that there's a lot there. It's just going to take the time to look to see that they're there. There's also amazing efforts like the Fairchild Tropical Garden has paired up with schools across Miami to have students, they document the lizards, and they're documenting native versus invasive lizards that are around Miami, and loading those up into places like iNaturalist, so that we have that documentation from the school kids. So I think that it's there. We just have to take the time and have the patience to notice it and to show them where to look.
Great insight. Let's see, one more question. Aside from the iNaturalist, which you've talked about, and I have actually seen before, for folks that want to get involved in protecting wildlife, are there any other organizations that you know that work either in South Florida, in Florida, or across the United States that are worth supporting?
Great question. I think others would probably be better at listing all of those. You know, you have things like IUCN, World Wildlife Foundation, organizations like that are working at continental to global scales. I'm just coming into Miami to learn what's here. So I've loved working with, starting to work with Fairchild Botanic Garden, Montgomery Botanic Garden. So we have rich botanic gardens here. I know that there's a zoo here, and I don't know yet what efforts they're making. I like to compost, and I've been looking at the different, I forget the name of the organization that's accepting compost rather than throwing that away. So we have lots of great area organizations that are good to get involved with. So I think simple Googles, and I think that there's some things being put up in the chat that are some suggestions for who to get involved with.
So much, Dr. Zanne. I think that's all the time that we have. I just, again, want to thank you for your keynote presentation and for all of your insight, and also for all the incredible work that you do right here at the University of Miami. Thank you so much.
Thank you. Thanks so much, Olivia. I appreciate the invitation.
Yoka, back to you.
Thank you, Olivia. Thank you, Dr. Zanne. We are in the midst of the sixth mass extinction. Biodiversity is essential for the processes that support all life on Earth, including us humans. Without a wide range of animals, plants, and microorganisms, we cannot have the healthy ecosystems that we rely on to provide us with the air we breathe and, of course, the food we eat. So thank you so much for that powerful presentation.